will talk about the logic instructions in 8051. So the first logic instruction is AND. So we have AND or XOR or like that. So AND operation. So the syntax for AND operation is ANL, that is logical AND, destination comma source. So what is done is the destination register content is ANDed with the source register. Okay, so these two are ANDed and the result will be stored in the destination. So ANL is the operator mnemonic. So what is done is AND operation is done between two operands and place the result in the destination. And the destination is normally the accumulator. So for all these logical operations, the destination register will be the accumulator itself. And the source register, it can be immediate addressing, that is a value, or it can be a register, um, that is the content of the register will be added with the content of the accumulator, or it can be a memory location. So the content of the memory location will be added with the accumulator. And as I told, it can be immediate addressing also. So suppose we are using move a comma 35 and a comma 0 fh. So that means that 35h and 0 fh is ANDed. So this is 35 3 5, this is 0f. So what happens here is, see, here it is 0f. So ANDing with a 0 means that the resultant value is 0. So you can also say that the AND operation can be performed in a case where you want to set the result to 0, or a set of values to set of bits to 0. If there is such a case, then you can use the AND operation, that is the ANL operation. AND with 0 means the result will be 0. And with 1 we cannot say, because that will depend on the other operand. Okay. Next is the OR. So that is also ORL. The other one was ANL. This is ORL, destination comma source, just like in the earlier case. And the destination is normally the accumulator and the source is like in the case of AND operation itself. It can be immediate, it can be a register content, or it can be a memory content. So likewise in the earlier case, again OR operation, just like a normal logical OR operation. So here if you see, ORing with 1 means the result will be 1. So if you want to set a set of bits to 1, then you can OR it with 1. Okay, so if you want to change certain bits to 1, then you can OR those bits of the source with a 1, so that the result will be 1. So in the AND operation, if you want to mask or if you want to set the result to 0, you can use the ANDing with 0. ORing with 1 will make the result equal to 1 in those specific locations. Next is XOR. So again, the syntax is the same in all the cases: ANL, ORL, XRL, destination comma source. So operation is the same, just only the basic function will be different. The destination is the accumulator in all the cases, and the source is also the same in all the cases. It can be a register, memory, or the immediate addressing. So XORing with 1 means, if you are XORing, say with XOR, see here you are XORing with 1. So 1 becomes 0, 0 becomes 1, 1 becomes 0, 0 becomes 1. So if the source is of a particular nature and you want to toggle the source, the result you want to toggle means what? Complement. Okay, so if you want to complement the bits in the source register, then just XOR it with 1. If you XOR it with 1, then the 1s will become 0 and zeros will become 1. So AND operation, OR operation, XOR operation, ANDing with 0 will give you a 0 at the result, ORing with 1 will give you a 1 at the result, and XORing with 1 will give you toggled output or the complement of the output. Uh, Also, it can be used to XOR, can be used to clear the contents of a register by XORing it with itself. Okay, so if you want to clear a particular register, then or say accumulator, then you can XOR it with that particular value itself. So XRL A comma A means it will clear A, but then clearing A is, you have other operator also, CLR A, that will also clear the accumulator. Okay, so XORing with itself will give you clear 0. Okay, so this we can do in HSIM. Sorry, not CLR, it is CPL. Sorry. So complementing the register CPLA. Okay, so that is similar to CPLA, similar to XRL A comma A. Both are the same. Sorry, again sorry. Uh, Now this is complementing, not clearing. This is complementing. XRL A comma A will clear the contents of the accumulator. CPL A will complement the contents of the accumulator. It is equivalent to XRL A comma hash 1. Okay. Um, and if you want to get the 2's complement, just add 1 to the complemented accumulator. So CPLA, then add A comma hash 1 will give you the 2's complement. CJNE we have already discussed in the very early classes. CJNE destination comma source comma relative address. So it is actually compare and jump if not equal to. So we dealt with in earlier classes. It changes the carry flag to indicate if the destination operand is larger or smaller. Compare and jump if not equal. So if the destination is greater than or equal to source, carry flag will be set to 0. Destination is less than source, carry flag will be equal to 1. So in CJNE, you can use a register. You needn't use an accumulator. In many of the cases, the destination should be the accumulator, but in CJNE, the destination needn't be an accumulator. It can be a register, any register. Another compare, that is a compare instruction. So a logical instruction, we had ANL, ORL, XRL, and CPL is the complement. Okay, then you have the compare instruction, CJNE. So also you can try in EdSim. Write a program to read the temperature and test it for the value 75. You have to read the temperature first. So where will the temperature be read from? From a port. Okay, so one of the ports will read the temperature, and you have to compare it with the value 75. And if the temperature value is 75, then A is accumulator is 75. If T is temperature is less than 75, then R1 is equal to T, and whatever is the value of T. And if T is greater than 75, then R2 is equal to T. So P1 equal to 0 FF is just to make it an input port. We know that to make a particular port as the input port, you have to make all the bits equal to 1, and to make it output port, you have to make it all equal to 0. But in EdSim, you don't need to make it an input port, because by default it is 1 when you switch on the EdSim, when you load a new program into EdSim. So you are typically making P1 as the input port, and you are reading in, suppose P1 is the port from which you are going to read the temperature. So you are reading the temperature from the port P1 and moving that value into the accumulator. And then you are comparing the value in accumulator, that is the content of the P1, with 75. Compare and jump if not equal. So the value of the temperature read from P1 is compared with 75, and if it is not equal, then jump to over. Yes, and then if carry is equal to 0, then A is greater than 75. That is, compare and jump if not equal to means actually what is happening is subtraction. Okay, so if the accumulator content, that is if the temperature read in from the P1 is say greater than 75, then what happens? Compare instruction is really a subtraction. Okay, so the flags are changed at the execution of the subtraction instruction. So CJNE A, 75 means subtraction is happening, but then the value of the accumulator will not change. Only the carry flag will be set to 1 or set to 0, depending on which is greater. Okay, so so if A and 75 is compared, then that means that A minus 75 is done, and A minus 75 will be a positive value, that is the carry flag will be 0 when A is greater than 75, and if A is less than 75, then the carry flag will be equal to 1. So that is used here. So compare and jump if not equal to. So if it is equal to, then that means that accumulator value is equal to 75, the first case. Then you have to compare these two. T is less than 75, T is greater than 75 by checking the carry flag. So Cy is equal to 0 means A is greater than 75. If A is greater than 75, then R2 should be T, and if A is less than 75, then R1 should be T. What is T? The value of the accumulator. Okay, so that is what is done here. And after each comparison, you're just leaving, exiting and leaving the program. Next set of instructions is rotate. So this may be new to you. So rotate, you can rotate to the right, you can rotate to the left, you can rotate with carry to the right, with carry to the left. So there are four types of rotations basically. So what are you rotating? You are always rotating the accumulator contents. Okay. So RRA means rotate right the contents of the accumulator. So accumulator, you know that it is an 8-bit register. So those 8 bits are rotated to the right. So this is how you rotate. So you are rotating from MSB to the LSB, and what happens to the LSB? It will rotate and come here. So D0 comes to D7. So once if you rotate RRA, just one RRA means D7 will go to D6, D6 will go to D5, D5 will go to D4, D4 will go to, sorry, okay, D7 will go to D6, D6 to D5, D5 to D4, D4 to D3, D3 to D2, D2 to D1, D1 to D0, D0 to D7. That is RRA. If it is rotate left A, then it is just the other way around. That is, you will rotate from LSB to MSB and MSB will come to the LSB. So here we can see rotate right. See, A is 36, 36. 1 RRA means this 0 comes here and everything other will shift one position. Next RRA means again this LSB will come to the MSB. Other bits are shifted to the right. So that is what happens in RRA. And in RLA, it is rotate to the left. So the D7 will exit and enter D0. In RRA, it was the other way around. D0 will exit and enter D7. So if it is 72 accumulator content, then RLA means this 0 will come here, this 1 will come here, this 0 will come here, this 0 will come here, this 1 will come here, 1 will come here, and this 0 will go here. So that is RR and RL. Next is rotate with carry. So rotate to the right with carry and rotate to the left with carry. So rotate to the right with carry is just like in the case of RRA. The only difference is that in the earlier case D0 would go to D7. In this case D0 will go to the carry flag and the carry flag will go to D7. That is rotate with carry. So carry is kept here. D0 will go to the carry and whatever was there in the carry flag that will go to D7. Rotate to the right, left with carry is also the same. Carry will come here. So D7 will go to the carry and carry will go to D0. So A is 26. Here our carry is 0. So rotate to the right with carry means carry here is here. Carry was 0 earlier. So you're rotating and this 0 would come here and the earlier 0 would come here. So this one, this will come here. Okay, and rotate to the left with carry is same. The carry is here. So D7 will enter the carry and the carry would go to D0. So this is a program which you can try. Write a program to find the number of ones in a given byte. So here they've cleared a register called R1. R7 is just taken as a count, that is there are 8 bits um, in a byte, and suppose the byte which you are testing is 97 and that is loaded into the accumulator, and you're rotating to the left with carry. Okay, so when you're rotating to the left with carry, you'll be checking the carry each time. Okay, so if there is a carry, so rotating to the left with carry, so you're shifting the bits to the left. How many times will you shift to the left? 8 times. Why? Because there are 8 bits in a byte. So you'll be rotating 8 times, and every time a carry is set, a register will be incremented. So number of times the carry occurs will be equal to the value in the register. Every time a carry occurs, a particular register which was initially 0 would be incremented. So first time carry occurs, the register becomes equal to 1. Next time the carry occurs, the register becomes equal to 2. So jump if no carry. If there is no carry, then you'll be checking the next bit. If there is a carry, then increment R1, which was initially made equal to 0. So these are simple programs, but you'll have to do and see whether you can write it on your own. Only then will you be able to apply the logic for a particular question, and also remember the syntax and how to structure the program.